So we have learned about how to deal with the system of coplanar forces. So what we learned is that all the forces can be reduced to a single force, which is called a resultant, and a couple, right? So from the basics, you know that this resultant can be applied at any point on this line. So this is called, what do you call this? This is called a line of action, right? So my handwriting is not that good, so bear with it. Okay, now so this is a line of action. So how do you find, so every line in the coordinate plane has an equation, right? So what is the form of the equation? The form of the equation is y equals mx plus c. But in this case, there will be no c because it is going through the origin, right? So what is m here? How do you find the m? So in this case, how do you find the line of action? Let's say, so y equals mx plus c. This is the usual form, but since this is going through 0 and 0, when you substitute 0 here, m0 plus c becomes 0, right? So the general equation will be y equals mx only. But still, you don't know what m is. How do you find m? Right, we discussed is that if this is theta, so tan theta will be given by the components of the r. Say the components of the r are y and x. So this is given by capital Y and capital X. Capital Y means all the components in the y direction. Capital X means all the components in the x direction, summed up, right? So m here is also y divided by x, capital. Okay, you can still see me. Now the equation will become, replace m by capital Y over capital X times simple x, right? Okay, so this is the equation here. In addition to this, you have a couple as well. Now let's see. So when you reduce all these forces, you are left with a resultant force and a couple, right? So both of these are not zero. But what if you want to find the line of action of R where there will be no couple, right? How do you find that? You want to reduce the system. Now we have R and G, but now you want to reduce the system only to a single force. So you have seen earlier that if we have a force someplace, if we have force like this, and if you want to transfer it to a point, what you do is you can transfer, but you have to introduce a couple FT, right? Now you saw that we have a resultant force and a couple at the origin. Now if you want to reduce it to a single force only, what do you have to do? You're simply going from here to here, right? So you have to find the place, you have to find the location of this line or the equation of the line such that the separation will be equal to G over F, G in this case, right? So I'll represent it now. Say R and G, right? So this is the force, this is R. Now let's say that when you displace R to a certain location here, so this is the line of action, the whole thing will be displaced but parallel, right? say this is the distance d here. So how do you find d? You can use g divided by r gives you d. This is the force, this is a couple, right? So if you want to find this line of action of r when the system is reduced to a single force alone, you know how do you find the equation y equals mx plus c. That is the equation. You already know m does not change, but you have to find c because now the line of action will not go through the origin. Okay, we'll see how we can do that. I have found a simple method. Let's see. So in this case, bear with me. So r here, r can also be resolved into two components. This is the x component and this will be the y component, capital Y. Okay, and this is the line of action. Now if you want to now displace this r, let's say to a point O dash. Okay, this is O origin, this is a new origin. Any point on this line, you still have the components of r. They do not change. Why? Okay, so instead of dealing with r alone, you have g here. Instead of dealing with r, we can deal with the components y and x. Now you see that when I displace this force, when I transfer this, you know that the x component of r will not introduce any couples here. Transfer it, it will not introduce any couples, right? But y will, y component. Okay, now how do you find the distance d here? So y into d has to cancel out the couple here. So the couple is in this direction, so y will be in the other direction, so both together will cancel out the couple. This should be equals to g. So d here will be g divided by capital Y. Okay, now what is the form of the equation? Equation is y equals mx plus c. Now we know this point. What is this point in the Cartesian coordinate plane? The x value is d and the y value is 0. Let's substitute it here. Y 0, m, you know, capital Y divided by capital X, and x here, x becomes now d. How do you find d? D equals g over y plus c. Now this gives you y cancels out, c is given now minus g over x. Okay, right, let's erase this thing for a moment. So now you know c and you already knew m. So what is the equation of the line? The general equation will be given by y over x minus, instead of c we write g over capital X. Okay, now I'm going to multiply by x, which gives me, this is simple y, which gives me simple y capital X minus simple x capital Y plus g equals 0. Right, so now this is in the form of y equals mx plus b. Well, not exactly in the form of y equals mx plus c, but you can rearrange it to that form. So this is called line of action on a system of a single force only, right? Okay, you have any questions, please let me know.